layers, TCP, IP, and OSI models or layers, they're kind of like tells you the journey of a message. When you send a message over the internet, it will tell you the journey, like what the message goes through. At first, it starts encoding and compression, then start segmentation, then like you have to add some destination information, and so on up to until it goes through the physical layer, which is the communication channel. Then at the receiver part, now these segments, when they arrive, they will be connected together or assembled together, and then until you get the information at the receiver side. So the outline of this lecture, we're going to talk about the OSI model. If I may add, like it will be a class activity on packet tracer routers, then TCP IP model. Now the critique of both is going to be like within the TCP IP, like every now and then we'll see slides, like what is the similarities and the similarities between both. Oh, okay, so the OSI model, we talked about it last week, but not in detail. So basically, to address the problem of networks increasing in size and in number, so the ISO community, the International Organization for Standardization, like they researched, like there are many network schemes and recognize there is a need to create something default or common to all. Now, again, imagine that back in the early 80s, this networking concepts was very new. So instead of each company creating its own platform or its own protocols or its own methods of communicating, the ISO community, the International Organization for Standardization, thought about, okay, why don't we unify these protocols or these schemes so everybody in the world can follow the same thing, and it will save a lot of work and a lot of hard work when it comes to design networks. So they released the OSI model in 1984. So that was about 36 years ago or 37 years ago. So these some conventions here or abbreviations. ISO, the International Organization for Standardization. And this one is not just for networks, like everything here, like something related to quality, you have the ISO 9001 standard. Like you have, yes.
Did you take the attendance?
Yes, remind me at the end of the lecture.
Okay, because I was having a problem when entering.
Okay, no worries. Okay, the OSI model is the open system interconnection. So it's an open, let's say, method or open protocol. Everybody can use it. iOS, the Inter-Network Operating System. So those are abbreviations. Notice like it's just the 3 letters ISO, but just changing the order will change the definition. I suggest you memorize these abbreviations. What does ISO stand for? What does OSI stand for? And what does iOS stand for? Okay, so the OSI reference model consists of 7 layers. It starts in a descending order. Number 7 is the application layer. Number 6 is the presentation layer, session layer, transport, network, data link, and physical layer. Now, in each layer or in each step, something will happen to the message you are trying to send. And it starts from the application. Let's assume this is the sender side. It starts from the application. Now, in this slide, I want you to memorize the layers and their order. A common question I might ask in the exam, I will give you this table with 7 spaces, and I'll ask you to do some matching. So, and I'll have the choices somewhere, and choice 1, application layer, sorry, layer 7, application, layer 6, presentation, session, transport. And we need to know the job of each layer. So everybody who is dealing with networks will be dealing with the OSI. So I suggest to memorize it in order, and each layer, what does it do? Okay, so let's start with the application layer. From its name, it's an application. Let's say, think about an email client. You want to send a message. So, or a web browser. You are browsing the internet, you make requests. So all of these things are applications. So the application layer is the software that you are using on your computer to interact with the network, like something you can make a request with. So imagine you are sending an email. So the application Outlook is your application layer. PDU stands for Protocol Data Unit, and in this case is the user data. So basically, I want to send a message. So the data unit here is data. Now, the second layer is presentation. Now, if I want to send a message, how to present it? So in this layer, it's responsible of presenting the data in case like you need some encryption or you need to do some compression. You do not do any segmentation here. Here, the presentation is like how you want to present the data. You want to send data, how you want to present it. So do you need to do some compression? Like this text file, its size is about 100 kilobytes, but is there a way to send it in like 50 kilobytes to save space? So that's one, compression. And encryption, you want your data to be protected. So you there are some means of encryption and hiding the information. Now, in this case, the output or the protocol data unit is also data, but it's a formatted data. Now we have the original data from the application. Now, once it passes through the presentation, I have formatted data. All right, now then we will have the session data. Now, this layer establishes, manages, and terminates sessions between two communication hosts. Now, in this case, I want to send the message. The session layer will be responsible to make sure that, okay, is there a connection to the destination? Like, do I know the address? Is there any means of communication through a router or through some network, wired network, and so on? So this is the job of the session layer. So in this case, the data, there will be no change, but the only thing we do is just you have to add information about the hosts. The host could be the sender or the receiver side. So it establishes and manages and terminates the sessions between two communication hosts. So in this case, an example, the client software. So this is at the other side, the client software. And the output in this case is another set of formatted data, but with some addition. And we'll see a chart later on, like at each layer, we will add something we call headers. And this is just information you add to the original message. And this information is responsible of doing certain jobs. Okay, now the transport layer. Now let's imagine like the data is large. So it is responsible to break up the data into segments and send these segments with a certain order. Now, okay, breaks up the data, sending host, and then reassembles it in the receiver. So if it's, let me do a proper slideshow. Okay, so yeah, at the sender side, it breaks up the data. At the receiver side is assembling the data. So again, these layers, they are at the both sides, at the sender and the receiver. Right now, we're talking about the sender. It is also used to ensure reliable data transport across the network. Again, you do some segmentation. So let's say you segmented the data and assume that you have a large file. Now you divided it into 10 packets or 10 segments. Now these segments, they will be on order, of course. So in order to ensure that there will be a reliable data transport, each segment or each packet will be labeled with a number, like this is packet number 1, this is packet number 2, and so on. So in order, let's say, once this information or data received at the other side, it will easily arrange the data to get the original message. And in this case, the output is the segments. So if you go back to the application, I have the user data, the original data. Presentation, it will do some compression and the encryption. So I have a formatted data. Session layer is responsible to make sure that there is a connection between two hosts, the source and the destination. And the output also will be another set of formatted data. Now the transport layer, it will break up the data into pieces, and the output will be segments. And all of these things, they're just happening in your computer. We are not in the network yet. Up till now, all of these information are within the computer. The data is not sent yet. Now, this is going to be the job of the network. Now, the network layer is also referred as a Cisco layer, so keep that in mind. A typical question will be a layer that is known as the Cisco layer. That is the network layer. So the network layer, it makes the best path determination. Because if you think about it, there are too many routers, there are too many paths, like there could be hundreds of combinations of paths. So the Cisco layer is responsible to determine the best path And that could be based on the availability of some certain routers, or based on traffic, and based on logical addresses. And this is usually going to be the IP address. We're going to talk about IP addresses later, inshallah, in the course. Now, the output in this case is the same thing, it's packets. Now, these segments, they have another name called packets. So yeah, the first one is segments, and the other one is packets. It's the same thing. Okay, so the network layer determines the path, data link. Think about the data link as the post office. Now it has the data, now it's ready to send it. So this layer provides reliable transit of data across a physical link. Again, think about the data link layer as the post office. It got the message, now it's ready to send it. So it makes sure that the data transmission across the physical link here, it could be Wi-Fi, it could be wireless, it could be fiber optics, coaxial cables, and so on. So this is like the media that message transmitted on. So it makes decisions based on the physical address. Now, something we will see later is the medium access control, or the MAC address. Each network component in the world has a unique MAC address. So, and this is the job of the data link. So the decision will be based on the medium access control addresses. And in this case, the output will be frames. It's pretty much like this first one. So we have segments, packets, frames. Now, physical layer, now you are ready to send the message throughout a certain channel. So this is like the media where the information is sent. I think next week, inshallah, the chapter will be on media. Examples, the Cat5, like what we have now is the RG45, you know, the Ethernet cable. There are coaxial cables like the TV cable. And nowadays we have the fiber optic, which is hundreds times faster than the previous two. Now, we have these 7 layers. So let's see an analogy like this data or this information or these layers. In real life, if I want to apply this 7-layer model, how it will look like. So let's take this scenario. Someone who's riding a bike, he wants to send this message or this bike to his friend in UK. So after riding your new bicycle a few times and you are, let's say, feel satisfied, now you decide that you want to give it away to a friend who lives in London. So think about the bike as the message. You want to send the message from a source in here in Dubai and a destination in UK and London. So this is the first thing. You want to send data. You want to send information. So you want to send the bike to a destination. So this is the application. You want to send something. Okay, now the second layer, which is the presentation layer, you just look into the manual on how to assemble and disassemble the bike. So of course, you're not going to send the bike as a package. So you decide to disassemble the bike into smaller pieces. Okay, is anybody sending messages here? Let's see.
أنا دكتور.
All right. Yeah, regarding attendance, please remind me at the end of the lecture. Also, yeah, thanks for bringing up this topic. I'm thinking of creating a Telegram group. Why I prefer Telegram, phone numbers will not be shared, and we can talk freely about it. And I'll send you the link for the Telegram group over Moodle or over the email, like in few days, inshallah. So yeah, this one is a good idea because let's say I make an announcement, like we're gonna have a quiz next week. I did not discuss it in the class, I may forget. So Telegram will be a way of communicating between us. And the good thing about it, it's pretty much like WhatsApp, but phone numbers will not be shared. So like I prefer to keep numbers private. Okay, again, late entrance. I understand some people have technical issues with Zoom. That happens, no worries at all. Please remind me at the end of the class. All right, so let's go back to the presentation layer. Then you look for a manual. So you look for the proper directions to disassemble and reassemble the bicycle. All right, so this is pretty much like the encryption or compression. That's in the data domain, but now in the physical domain, real life domain, it's like you are assembling, you look for a manual to disassemble the data. Now, session layer. So you talk to your friend in the UK and make sure that you have the correct address. So this is like a logical kind of communication. So once you get the address, now you are, let's say, you're gonna say have the bicycle, you have it in pieces. You're gonna get each piece into a proper packaging, and you put the address in each package. But you also organize these boxes. So this is box number 1, this is box number 2, this is box number 3, and you can tell the receiver that, okay, in box number 1, there are these pieces, box number 2 and 3, and so on. So you disassemble the bicycle and put different pieces in different boxes. The boxes will be labeled 1 out of 3, all the way to 3 out of 3. So this is it. This is what happens at your home. You did not go to the post office yet. You did not send any information. This is at your house. And that's what I mentioned. The first 4 layers, layers 7, 6, 5, and 4, they are within your PC. You are not at the network yet. Now, the network layer, now you are ready to start your communication. So usually if you want to send a letter, you bring an envelope and write the source address and destination address. But now since you are sending packages, so you put the address on each box. So put your friend's complete mailing address and yours on each box. Now, since the packages are too big for your mailbox, and since you don't have enough stamps, you determine that you need to go to the post office. Yeah, but assuming that you want to send a message, and I think here you have to go to the mailbox, to the post office. Like you usually find the mail, what do you call it, the mailbox at front of houses here. So yeah, you decide to go to the post office to send the messages. And there you go. And as I mentioned, the data link layer is the post office. Now this one has information about all medium access controls or MAC addresses in the world. So this one knows where your destination is. So it received the packages, now it's ready to transmit them. And the best way to transmit information or to transmit stuff from Dubai to UK is using this physical media, and this is the airplane. So that's it, that's from the sender side. So remember, you started with, you send the message, or you want to send the bicycle, and this is your application layer. Next, you have the presentation layer. You look for a way on how to send the bicycle, so you decide to disassemble it. Then you're gonna call your friend with the session layer, confirm his address. Then at the 4th layer, you segment, you put the bicycle into boxes, and that will be, let me remember, it's the transport layer. Yeah, so this happens at your home. Then you put the address on each box, you give it away to the post office, and they will send it. Okay, so this is at the sender side. Now at the receiver side, what will happen? So this is the first thing, the physical layer. This airplane has stopped in UK. So the boxes are flown away from UAE to UK. So this is what happens. So this is the first thing. It receives the message through the physical layer. Now we're gonna go in a reverse order at the receiving side. So we start with the physical layer. Now the data link layer knows where the destination is. So the post office will receive the boxes. It knows where the destination is. Now it looks at the address. It will know where the destination is, so it will send the boxes directly to the address. So upon examining the destination address, London Post Office determines that your boxes should be delivered to your written home address. So this is the network layer here. Now after that, the transport layer. Now remember, at the sender side, you segment the data, or you put the data into boxes. Now the receiver side will be the opposite. Now you're gonna assemble the pieces of the bicycle. So your friend will call someone that he got all the boxes, and he's having another friend named Ali reassembling the boxes. So basically reassemble the boxes. Then your friend will call you and will confirm that he received the message. So your friend hangs up because he is done talking to you. Then the presentation, for some reason, like you can put it inside the box to present it as a gift. Then you can, or your friend in the UK will play with the bicycle. So this is an analogy on how to do it. If you understand the network terms, that is fine. If you find it hard to understand the network terms, you can follow this analogy and hopefully it helps. So enough with the analogy, let's proceed with the technical terms. So this is the host layer. So these things, as I mentioned, they are within your computer. These layers only exist in the source and destination host computers. So they are not in the network yet. The data is not sent yet or is not received yet. Now the other three, they are the network. So these layers manage the information out, like in the local area network or wide area network, between the source and the destination hosts. So this is within the PC, those within the internet or the media. So this is a way of representing it. So let's assume that you have device A and you have device B, and you want to send information from device A into device B. Now, there are two ways to communicate. So it could be peer-to-peer networking, like you have a direct LAN cable from one computer to another. So there will be no need for a network. You can have this connection. Peer-to-peer, I'm sure you guys heard about it. A torrent is an example of that, though it's illegal. But that's the peer-to-peer network that there's no need for internet. You just basically have a computer and a laptop that are connected with the Ethernet. There is no internet needed to make such connection. But what if you want to need, let's say if you have to use internet? So all of these things will happen here. So you have at the application, there will be some certain interface between the application and the presentation layer. Then go to the session layer, transport layer. Now, once you go to the network layer, data link and physical, so it will go through this node, and this node will consist only with these layers, network, data link, and physical. So usually think of router as a point like this. So this is the router, consists of these layers only. Another router, and at the destination, it will receive, and it's going to go back in reverse order. Physical, data link, network, transport, all the way to the application. And with this, you completed the communication. So forget about the peer-to-peer. This is assuming a direct connection between two computers. But in this one, the classic way, you have to go like a letter U. So you have to go all the way from the computer, going over all the layers, and finish to computer B. Okay. Now this one, the process, what will happen? Like, what do you mean layer 1, layer 2, layer 3? So what will happen is like this. So you have the data, and this is layer 7. This is the application layer. Now at the application layer, you send the data. It will pass through the presentation layer. Now H6 here, forget about the number 6, but H6 is header. This means like I have my original data, but I added to it some extra data to do some certain task. And this is what we call header. And this is 6 because it's like layer number 6. That's the presentation layer. Now the session layer, that's header 5. And started L7. Now L7 and H6 is L6. We added some header so that I'm adding some information. Now at the transportation layer, so another header. The network layer, another header. Data link layer, another header. Now at the physical, I have all of these. Now think about it. This is your data, original data, but look what you are sending. You are sending all of this information. So there'll be a lot of not unnecessary data. They are necessary to make sure the connection is complete, but you are sending more controlling data other than the original data. Now in here at the at the data link layer, now we do not add a header, we add a tailor also. So it's not just header only, there is a tailor of data. So this one to make sure this is the beginning and the end of a certain packet or a certain data. Now it will be transmitted through some certain channel. Now you look here at the receiving side. Now we're going to use the headers and tailors at each case or at each layer to perform a certain task. So wherever we have headers here, is going to be the same headers at the receiver side. Because these headers carry information, for example, the address, the IP address, or the type of data, whether the data has been encrypted or not. So this is what actually happens. So at each layer, we add headers, and at the last layer, we add a tailored data. So are we clear on this one, like how the process goes?
Yes, doctor.
All right. So please memorize these kind of things because you will be questioned about it. At the beginning, it might sound like memorizing, But if you think about it, it's like a logical order. All right. Now, the data flow in a network. Now, this is what, like, as I mentioned, the job of the network layer is determine the best path. Now, let's think about sending data from point X into point Y. So you start from router A, and router A can see these two routers, this one and this one. Now, router B can see these two routers, C and this one, and this also router can see this router. However, what will happen is, okay, so application and presentation, session, transport. Now, at the network layer, it decided that between the two layers or between the two routers, it was best to decide on router B other than this router. Now, at router B, it found out that router C is, like, say, a better connection than this router. And this router, it was my destination. So this was the job of the network layer. All right. So this is what we mean, like the job of determining the best path where the network will go or the data will flow. So data flow in the network focused on layers 1, 2, and 3 of the OSI models. Now, this is after being transmitted by a sending host and before arriving to the receiving host. So it's sending with these layers. So the network here focuses on those. Now, the first or the upper four, layers 4, 5, 6, and 7, they are only in the host, let's say source, and the destination host. So this is it about OSI IP model. Okay, so what we have done so far is the OSI model is an international model.
Sir, you didn't say my name.
Okay, remind me at the end of the lecture.
Okay.
Okay, for say we did the OSI model, it has been introduced back in the mid-80s. It worked fine, everything was fine, but then the TCP IP model has been introduced. The TCP is Transmission Control Protocol / Internet Protocol model. So why another model? So the OSI models work fine, is universally recognized. So people nowadays still they're using the TCP IP model. It's been more open, let's say more open standard of the internet. It's, let's say, for nowadays usage, people prefer the TCP IP model. So the reference model and the TCP IP protocol stack make data communication possible between any two computers, anywhere in the world and nearly in the speed of the light. So these are the advantages of TCP IP over the OSI. If you want to have reliable communication anywhere between any two computers with very fast communication, TCP IP model is the one introduced. And nowadays, I believe you'll rarely find any company or organization following an OSI model. Everybody's using TCP IP model. So if you were given a question, what are the advantages of TCP IP over OSI? This is the key sentence here. So data communication is possible between any two computers, anywhere in the world, and nearly the speed of the light. So we have three components or three main differences. So if you want, like, remember, we have the critique of both. So this is the first comparison. It's globally recognized. You can contact any two computers anywhere, and it's going to be fast. Now, the TCP IP model has been introduced by the US Department of Defense because they wanted to make a model that is reliable, that is secured, and something that works even at the worst conditions. Like even a nuclear war. Like imagine this, when you have the world in chaos, still the TCP IP model is more reliable. And that was the goal, the US Department of Defense, that was their reason for building a new model over the OSI. And by the way, don't be surprised, the TCP IP model started from the army. If you go back to the history of the internet, the basic or let's say the basics or the early networks, it was in the army level. And then it was released to public. Okay, so we have two models. The one here to the left is the OSI model. The one to the right is the TCP IP model. Now, in terms of memorization, it's easy to decide that TCP IP is easier to understand. It has only 4 layers. while the OSI has 7. However, even though it has 4 layers, but like you can say that, okay, the application layer here is a substitute for the 3 layers here. So application, presentation, session is equivalent to the application layer in TCP/IP. So an easy conclusion here, like what is the job of the application layer? So you have data. This could be encrypted or compressed, and it is like you can initiate the communication with the destination session, because this is the job for each layer here. Application, you want to send your data. So you have the data through some email client, you want to send it. So this is the application. Presentation, whether you want to do some compression or encryption or any other data modification. And the last one is the session, like where you want to initiate a contact with a destination. All of these things is the job for the application layer here. Now, transport and transport, they are exactly the same. The transport layer here basically will segment the message into packets and send it over the, let's say, the internet. So again, these 2 layers here are within your computer. Network layer, internet layer, they want to make sure that the message follows the ideal path. So this is the job of the network layer, to find the ideal path where the message should go through. Data link and physical, they are the ones responsible of sending the data over such media. So here we have the network access. Network access basically is the one that controls the flow of your data over the network. And that's why they call it network address. So network address here is the combination of data link and physical. So there you go. This is the OSI and this is the TCP/IP model. Okay, so in terms of comparison, as I mentioned, we have equivalent job. Now the application layer, okay, it handles high-level protocols, issues of representation. There you go, that's the presentation layer. And encoding, this is job of the presentation also. And then the dialog control, which is the job of the session layer. Dialog control, that to make sure that there is a secure connection or there is a path or connection to the destination, like information about the destination. A simple example is the IP address of the destination. So these protocols, including, so for file transfer protocols, we have FTP, we have NFS, TFTP. For the email short message, STP, SMTP, Telnet. You don't have to memorize those unless mentioned otherwise later. Then for me, I prefer to understand before understand that, let's say, enhance the memorization. For now, application layer here is equivalent to what we have, the 3 layers in the OSI model. Now the transport layer, transmission control protocol, TCP, and user datagram protocol. So we have 2 protocols in the transport. So keep that in mind. So connection oriented, you want to make sure that the message has been sent and like you receive a confirmation. Here is connectionless. You just send data. You don't worry about whether it was received at the other side or not. So it's pretty much like a broadcast. So the transport layer provides transport services from the source host to the destination host. Again, in the OSI model, we said that it segments the data into packets and send them over the to the network. So it constitutes of a logical connection between these endpoints of the network. Transport protocol segment and reassemble. There you go. That's exactly the keywords in the OSI model. Segment the data. If you are sending it at the receiver side, it will receive the segmented data and reassemble it. Okay, reassemble other layer applications into the same data stream between endpoints. Now the transport layer data stream provides end-to-end transport services. So the keywords here, we have 2 protocols for this. The transmission control protocol, that's 1. We have user diagram protocol, there's 2. We're gonna go over them later in the class, inshallah, in this lecture, sorry. The job of the transport layer, the main job is to segment or reassemble the data. It depends. If you are sending it, segmented. If you are receiving it, you need to do reassembly. It wants to, let's say, it secures a logical connection between the endpoints of the sender and the receiver hosts. Okay, the internet layer. So we have the internet protocol, and that's why they call it the TCP/IP. because it has these two advantages over the OSI. The transport, it has the TCP. The internet layer has the IP, the Internet Protocol. Internet Control Message Protocol, ICMP. Address Resolution Protocol, ARP. Reverse Address Resolution Protocol, RARP. Let's not worry about those for now, just for sake of mentioning. We'll go over them later in the course. Now, the purpose for the internet layer, again, is to select the best path through the network. It's again, it's exactly the same as the network layer at the OSI model. Remember the routers analogy. So the router sees many routers connected to it, but it decides like this router is closer to my destination. Things like that. There are too many criteria the router follows. It doesn't have to be only this, like the distance. It could be if the router is busy or not busy, jammed, have a certain bandwidth. There are many criteria. Okay, so the main protocol that functions at this layer is the Internet Protocol. Best path determination and packet switching occur at this layer. All right, so the job of the IP, for the network internet layer, select, there we go, it's highlighted already. Select the best path and determine the packet switching occur at this layer. And the main example here, so keep in mind these keywords. At the previous layer, then transport, we have TCP layer. And this one we have the IP layer. Okay, now the network access layer is basically pretty much like the media layer or the physical layer. So the network access layer is also called the host to network layer. Now host, basically this is your machine, this is your computer. And this one, the network access will give you access to the internet. And that's why we call it host to network layer. So I'm going from the machine level, I'm ready to send my message over the media. So it's called the host to network layer. So keep that in mind. I will ask you you may be asked in the exam, what is the layer in TCP IP model that is known as host to network layer? It is the network access layer. Now, if the layer that is concerned with all of the issues, an IP packet requires an actual make a physical link to the network medium. So there we go. It is the one concerned with a physical link, like fast Ethernet, coaxial cables, these media. This is the responsibility for the network layer. Okay, it includes LAN, WAN. LAN is the local area network, WAN, wide area network. So it includes these details and all the details contained in the OSI physical and data link layers. So yeah, it's just saying that this network access is pretty much a combination of the OSI physical and data link layers. ARP and RARP work with both to the internet and network access layers. So these ARP and RARP is common between the internet and the network access. Again, if you go back to the internet layer, these are the protocols: address resolution protocol and reverse address resolution protocol. And let's not focus about them right now. We're going to mention them later in the class, how these layers work. So a comparison, and that's what we mentioned, the critique or the comparison between TCP/IP and the OSI model. So this application and transport, this is at the machine level. It's more into protocols, while this one is more into applications, like things you modify on the message, but this one is more into protocols. Now, the network here is internet, and network here is data flow layers. Like the transport, you segment the data, ensure the best path for the data, send the data, have it prepared to be sent over a physical media. So the TCP/IP transport layer using UDP is the user datagram protocol, does not always guarantee reliable delivery of packets as a transport layer in the OSI model. So what it means here, in the TCP/IP model at the transport layer here, remember we have TCP and UDP. Now, if for some reason the message was sent following the UDP protocol, now the UDP protocol basically sends the data but does not receive any confirmation whether the data has been received or not, or let's say delivered or not. It just sends the data. There's no confirmation. So if there is a case that the data has been lost, that's it. There's no confirmation about it. There is no info about it, no retransmission. That's it. The message has been lost. While at the OSI layer, there will be some confirmation. So there is an advantage here. Again, is that's the case for UDP. TCP, there is confirmation. If you send the data following of the transport layer, use the TCP layer, then the message will be fine. But if it was UDP, there is no guarantee that the message was delivered to the receiver side. However, in the OSI model, so there is confirmation there, and probably someone might say there is an advantage of OSI over TCP for TCP/IP. It's not that case. Again, TCP/IP gives you the choice. You can use UDP and you can use TCP. So if you go back here at the transport, sorry, there we go, transport, we have TCP and we have UDP. And we'll see later in the slides the difference between the two of them. Okay. So this is the comparison here. Now, more into the transport layer. So the transport layer provides transport services from the source host to the destination, establishes logical connection between the endpoints of the network. It includes the following basic services. So first thing, the transport, remember, we segment the data. That's if you are the sending part. If you are receiving part, it is more into reassembly of the data. So segmentation of upper layer application data, establishment of end-to-end operations. So it's pretty much like the session layer in the OSI model. Okay, now transport of segments from one host to another. So this is the job of the transport layer. From its name, transport. Okay. Flow control provided by sliding windows. Now we'll see what sliding windows mean. So and let's see, we will see why they call it sliding windows. It's pretty much like windows, but there will be some like a shift, and that's why they call them sliding windows. Reliability provided by sequence numbers and acknowledgements. That's in the case if you're using TCP only. UDP does not have such thing. Okay. So this diagram here shows you the two protocols. So the transport layer. Now saying that these applications, FTP, HTTP, SMTP, DNS, they are usually more into TCP. Think about it this way. You downloaded a file. So you are downloading a file from an FTP server. So you receive packets. Now this server is going to keep sending data until you send a confirmation or acknowledgement that the data has been delivered, nothing to send anymore, then you stop the connection. Email, nowadays you can send an email with a request of confirmation. So you don't have to, so there will be some acknowledgement to the sender side. Now, DNS and TFTP, they are the ones who does not require confirmation. They are more into UDP, user datagram protocol. So a typical question here will be asked, like which applications let's say are more into TCP kind of protocol, like which applications will follow the TCP protocol. So there they are. So we have DNS. DNS is common, it uses both, but the rest, they are strictly to TCP. Now for the UDP, it's only DNS and TFTP. And they're all gonna follow the IP, the internet protocol. And with the network access, whether it was a wide area network, a WAN or LAN. So in this slide, again, just correlate the applications to which transport protocol it is connected to. Okay, TCP is a connection-oriented layer 4 protocol. Layer 4 is from this one here. It's layer number 4, because if you consider this 7, 6, 5, and this is going to be 4. It's layer number 4 protocol that provides reliable full duplex data transmission. Now the word full duplex, I'm sure we're going to mention that later. We have simplex, half duplex, full duplex. Full duplex means that the channel, the communication channel, is capable of sending and receiving at the same time. So this is what full duplex is. Half duplex is you have the channel that can send and receive data, but each one individually. You cannot send at the same time. So this is half duplex. Simplex, from its name, it's simple. It's either sends, either receives. That's it. So we have 3 ways of transmission: full duplex, half duplex, and simplex. So TCP, it provides reliable full duplex data transmission. Why full duplex? Because you send data, you wait for acknowledgement, you wait for kind of a receipt that the data has been transmitted. So this is why it's full duplex. TCP is part of the TCP IP protocol. It's a connection-oriented environment. A connection is established between both ends before the transfer of information can begin. So basically what will happen, you have the source host and you have the destination host. Initially, the source sent a message to the destination, and that's what we call a synchronized message. Okay, it sends it like in this way: hey, like, are you available to receive data? So the source sends that information and starts waiting for the destination to reply. Now, if the destination is available, it can receive data, it will send a message, what we call acknowledgement. So it sends information to the host, to the source host, that, okay, I'm free, you can send data. Then connection will be established, then data transmission will happen, or data transfer. So this is what it meant here. Like, there is an establishment, connection establishment between both ends. TCP is responsible for breaking messages into segments, reassembling them at the destination station, resending anything that is not received. Again, this is the main advantage of TCP over UDP. UDP does not have this feature. It does not have any resending. Why? Because it doesn't have any information from the receiver that it received some packets or not. So yeah, this is only at the TCP protocol. And reassembling messages from the segments. TCP supplies a virtual circuit between end user applications. So the protocols that use the TCP, as I mentioned in the upper diagram here, FTP, HTTP, SMTP, and DNS. So we have FTP, File Transfer Protocol, HTTP, the Hypertext Transfer Protocol. I'm sure everybody are familiar with this. This is like what we have in websites, in the internet. SMTP, Simple Mail Transfer Protocol. This is more into emails. So there you go, SMTP, that's emails. It's the short message or simple mail transfer protocol, and we have Telnet. Okay, now the TCP segment format. Now this is what happens. Like, well, this is when they send a message. This is what, like, when TCP, if you're sending a message from a TCP protocol environment. So think about this stream, like each line is 2 bytes. From bit 0, or sorry, 4 bytes. From bit 0 to bit 31. So that's 4 bytes. Now, like the first 16 bits is the source port. And the other 16 bits is the destination port. So these are information about source and destinations. So this is the first 4 bytes. First 2 bytes. You know what's byte and bit, right? By now, I'm sure you guys know that. A byte is 8 bits. So here, until bit 15, I'm having 2 bytes for the source. I have the other 16 for the destination. Now, sequence number. Now, remember, we are sending segments. There you go, it's a segment. Now, these segments, they are in thousands, so you have to label them. So this is the sequence number. This is showing that this is segment 1, segment 2, segment 3, and so on. And this one here is the acknowledgement number. This is from the receiver side. Like, it will send back a message to the sender that, okay, I received package 1, I received package 2. So this one is acknowledgement to the segments it received. Now here are more into control bits. So there is a header, there is reserved 6 bits, there are code bits, window, there is checksum, urgent, options. So all of these things, think about here, they are more into control. There's no data. So we have 4 bytes, another 4, 1, 2, 3, 4, 5, and this like is optional. So you have 20 bytes already just for control. They are not your data. Your data is here. So this is just a header for your data. Remember, we have header 1, header 2, header 3. Now the TCP at the transport layer will add 20 bytes to your original data. All of these 20 bytes are more into control bytes or control information. A typical question will be, what is the length of the TCP segment header? The length is 20 bytes. Keep that in mind, 20 bytes. This is the value I want you to memorize. Forget about those details. But to control the data or the header data on your message or packet or segment, it is like you add 20 bytes to your original data. And this is the original data, and basically it varies. Every message has its own length. So are we clear in this slide? Any questions so far in TCP?
لا دكتور.
All right, so let me see the chat. Okay, now we'll talk about the UDP, the user datagram protocol. So it's connectionless transport protocol in the TCP. It's a simple one. Just exchange datagrams without acknowledgements or guaranteed delivery. So basically you send a message over mail, a regular mail, to somewhere else in the United States, like the classic mail. There is no guarantee at all that the message was sent or was delivered to the destination. You just sent a message. So error processing and retransmission must be handled by higher layer protocols. Now in the TCP, that's already with them, because at each packet you send, you receive acknowledgement. Like in this one, you don't have that. So in order to ensure reliable delivery, there are some higher level protocols will be added to it. So UDP has no windowing or acknowledgements. So reliability, if needed, is provided by another application layer protocol. It is designed for applications that do not need to put sequences of segments together. So the protocols that UDP follow is trivial file transfer protocol, simple network management protocol, dynamic host control protocol, domain name system. And again, those things, inshallah, some of them will be, we will go over them later in the course, inshallah. All right, so if you were given the choice between TCP and UDP, what will you use if you are sending data? Between TCP and UDP, if I ask you to do a small comparison, what is the main difference? Here's the keyword, acknowledgements. TCP has acknowledgements, so there is a guaranteed delivery. UDP, no, there is no acknowledgements. So the segment format here, notice that there is nothing about acknowledgements, so just source and destination, length, and checksum. While if you compare them to the TCP, so there's a sequence number and there's acknowledgement number. So those are the 2 or 4 bytes, or 16 bytes actually. Those are 8 bytes, sorry, 8 bytes that like make the major difference between TCP and UDP, the acknowledgement number. So there is no sequence or acknowledgement fields. So this is a simple example here. So a file is sent to a server using the trivial file transfer protocol, TFTP, using the UDP. And notice like, okay, the user sent a message, goes through this router. So this router chose this other router and so on, it goes over to the cloud, to the internet, received to another service provider, a destination, there is a switch, and there you go, this is the TFTP server. But there is no, let's call it back propagation or confirmation or acknowledgement to the user. He just sent a message. He has no idea whether the message was delivered or not. Now, applications that use the UDP, let's go over them just in like mentioning. So there are 3 types of applications that are best suited for UDPs: live video and multimedia applications. Let's think about YouTube. When you open a YouTube video, the video is running, but does it know that you completed the video or you stopped watching the video or you completed the video? So it just transmits data. It doesn't need any acknowledgement that the video has been played or all bytes in the video has been finished, and that's it. So live video and multimedia applications, they follow the UDP. So they can tolerate some loss. but there is no need for any delay. Now, simple request and reply applications. Applications with simple transactions where the host sends a request and may or may not receive a reply. Examples like the DNS or the DHCP. Let's say back in the day with the credit cards, not like now. With the credit cards, sometimes like you used to pay, and there is no guarantee that the payment has been accepted or not. So this is like one example of credit card payments. That's back in the day, but nowadays it's confirmed, like you receive a confirmation message, but back in the day there is not. Now, applications that handle reliability themselves. So basically they are unidirectional communications that like they can do their own flow control and error detection and acknowledgement and so on. They don't care about error recovery, and they can be handled by applications examples SNMP and TFTP. Let's not worry about this. Just memorize these basics like a live video stream, simple request and reply application, applications that handle reliability themselves. Again, UDP does not guarantee delivery to the destination. So this is a simple comparison between both protocols. The UDP is faster because basically it does not add a lot of bytes to your data, and there is no need to waste time on waiting for an acknowledgement. It just sends data. An easy example is internet protocol, phone, voice over internet protocol, IP phones. Low overhead. By overhead means that the additional data you add to the original data, the overhead. So it's low overhead. It was only 8 bytes, I believe. Let's see. Okay, this is the one, 8 bytes when compared to the TCP 20 bytes. So there is low overhead. Does not require acknowledgements. This is the key difference here. And does not resend lost data because there is no information about which information was delivered or not. Delivers data as it arrives. So yeah, it just does data delivery if it as it arrives. There is no confirmation. Now for the TCP, it's reliable because the sender will not send further information unless it receives an acknowledgement from the receiver. So there is an acknowledgement. If there are some data lost, it will resend lost data, and we'll see later now a diagram shows how TCP works. Delivers data in a sequence order. Basically, you have packet 1, packet 2, packet 3, and so on. So the data will be sent in a sequence order. So let's see an example here how the TCP works. So we have machine A, which is the sender, and you have machine B, which is the receiver. And the more you go down, that's the time. So this is the timeline. This is the timeline. Now, at the beginning, machine A will send a synchronized letter to a synchronized message to machine B. Synchronized, like I want to establish a connection. So are you free or not? Are you ready to synchronize or not? So this is a control message. It's not data at all. It's just a control message asking the destination if he's free or not. So the initiating client requests a client to server communication session with the server. Now, if the server is free, it will send acknowledgement of synchronization. So acknowledgement as sync, the server acknowledges the client to server communication session and requests a server to client communication session. Now, the machine B replied to machine A like, okay, I'm free, you can send data. Now, once the connection has been established, the initiating client acknowledges the server to client communication session. Communication has been established and data starts to be sent to the destination. Okay, so that's pretty much what we call a three-way handshake. So sync, that's the first one. Sync acknowledgement, that's the second one. And established, that's the third one, the establishment. So TCP requires connection establishment before data transfer begins. For a connection to be established or initiated, the two hosts must synchronize their initial sequence number, ISN. So this is the keyword here. Initial sequence number must be synchronized. What we mean by that, when this message sends back packet 1, this one should acknowledge with acknowledgement 1, packet 2, acknowledgement 2, and so on. So this is how it goes here. This is what we call a basic windowing. So it's pretty much like a window, and like it reflects light between both windows. So data packets must be delivered to the recipient in the same order in which they were transmitted to have a reliable connection-oriented data transfer. So if there was something wrong with a certain packet, the destination will send an acknowledgement message that this packet has been lost, resend it. So it will not send a packet until make sure that all previous packets has been acknowledged. So the protocol fails if any data packet are lost, damaged, duplicated, or received in a different order. An easy solution is to have a recipient acknowledge the receipt of each packet before the next packet is sent. Now this is how it goes here. So let's assume the connection has been established. Now this one sends message 1. Now over the time, the receiver received message 1, so it will send acknowledgement. Okay, there is an acknowledgement, send me message 2. So it receives acknowledgement 2, it will send message 2. There you go, receives message 2, it will send acknowledgement to send message 3. Receives the acknowledgement, sends message 3, and so on until all packets are done. Now here, window size is 1 because sending 1 packet at a time. And this is what we call window size equal 1 packet at a time. But you can have more windows. Like in this one here, I'm sending 3 packets at a time. So here the window size is 3. So the sender will send the first 3 packets. So the receiver received 1, 2, 3. Okay, I'm ready to receive packet 4. But the sender receives 3 packets. So receives acknowledgement for packet 4, will send 4, 5, and 6. Received acknowledgement to receive packet 7, and so on. Now, sometimes the window size varies or is not constant. Like in this case here at the beginning, the window size is 2, was supposed to be 3, but message 3 was lost. So it sent 3 messages. Packet 3 was lost. So it received message 1, it received message 2. Message 3 was not received, so it would send acknowledgement to the sender that, okay, send me packet 3 again. So the sender will send 3, 4 again, and 5, because it sends 3 packages at a time. Same thing here, package 5 was lost, it will send an acknowledgement, resend the packages. Now in this case here, the sender will know that, okay, that receiver only receives 2 packets at a time. So this one here, the slide